This is an 82-year-old male who presented to an outside hospital with abdominal pain. Abdominal ultrasound showed acute cholecystitis with a dilated bile duct and stones. The clinical course was complicated by sepsis with hypotension and acute renal failure. A cholecystostomy tube was placed and ERCP attempted but failed. He was transferred to our service, septic and unstable. An EUS guided rendezvous procedure was performed for biliary access. The cholangiogram showed a distal CVD stricture and complete cystic duct obstruction. He's been referred to us for internalization of the cholecystostomy tube.
This is a very challenging case, and the emphasis here is that this patient has significant comorbidities. He's 82. He is definitely not a candidate for surgery. And there's still some puzzling aspects to this story because he presented with cholecystitis, and then he had a cholecystostomy tube placed, but then he's also jaundiced. And the ERCP, as you heard, the initial one failed. A rendezvous was required to gain access to his bile duct, and a bile duct stent has been placed. And that stent is in situ. His numbers are improving, but he's still really, really sick. And so the concern is that his gallbladder is not draining adequately through the cholecystostomy tube. And we may be able to improve that with internalization of his gallbladder drainage. Let's look at the gallbladder. So this is the IVC and the aorta. On the left side is the IVC here, and this is the aorta. And we're going to turn around and look for the gallbladder. Sort of swivel around looking for the gallbladder. There's the bile duct. And what I'm going to do is push in a little further to see if I can find a good position to visualize the gallbladder. This is the aorta again, and the spine is below it. This is the IVC now. You can see there's ascites. There's ascites here. That's not a good thing, right? There's ascites. In other words, you're looking now at the gallbladder, but unfortunately, there's ascites. That means it's very obvious that this gallbladder wall is not adherent to the duodenal wall, right? I think everyone will agree there's no adherence between the two structures. So if we're going to place a stent to drain the gallbladder into the duodenum, we definitely have to have a system that allows us to immediately deploy the stent, and that stent should be lumen opposing so that it holds the gallbladder up against the duodenal wall. It should be fully covered so that you don't get any leakage of gallbladder contents or duodenal contents into that space between the two because they're not adherent. One should be able to deploy this stent without having to do any kind of exchange over a guide wire because if you do, then you're going to get leakage alongside the guide wire when you do the exchange. And I think the real challenge here is going to be the risk that as we penetrate through the duodenal wall and go into the gallbladder, the risk that we're going to push the gallbladder wall away and not enter into the gallbladder lumen. And this hot AXIOS, which is a cautery-enhanced delivery sheath, it's bougie-shaped at the tip, and it has fine wires running along the side, and it's been constructed, masterfully constructed by the engineers at Lumina, to enable the very quick, easy, and hopefully effortless penetration of the wall layers so that you can deliver the stent immediately into the target lumen without any risk of pushing the target structure away from the bowel wall. And we're gonna see if it works. I think this is the only chance this patient has. Otherwise, we're left with a patient who is deteriorating very rapidly. He has today more altered mental status than yesterday. He is still septic, so he is not getting better. And so the hope is that if we can internalize his drainage, and I think this is his problem. His problem is an infected gallbladder. So either you're going to have to take him to surgery and remove the gallbladder, and I don't think he'll survive surgery, or we need to drain his gallbladder this way. I think that's what we're left with in terms of choices. So it's a choice of two options, which both of which are not great, but clearly this is the lesser of the two evils, if you will, would be to try to drain this internally. And I do think we have a very good chance of succeeding. All right, with that said, let's bring the lights up just a little bit here in the room so that I can show you how we are going to insert the delivery system for the hot AXIOS. This device, I can tell you, is 10 years in evolution since I filed the patent in 2004. And now, a decade later, we actually have the full device. And this delivery system is a very key part of this, the success of this procedure. So what I've now done, and I don't know what you're seeing on the screen because I don't have an image here in front of me, but this is the handle, and it does have a swivel lock here, which means I can lure lock it, but I can move the orientation of the handle in whatever direction I'd like it to be so that I can see the front of the handle. And that's important because you have two components. You have a lower component and an upper component. That lower component with the distal hub here, I'll call it the distal hub, allows me to advance the sheath forward. That's no different than an FNA needle that you would advance forward to do an FNA. This more proximal component is for the deployment of the stent. So this is a proximal hub or an upper hub, and it allows you to deploy the distal flange completely independent of the proximal flange. And that's very, very key, that the two flanges are deployed independent of one another, and there's a full stop between the deployment of the distal flange and the deployment of the proximal flange. And basically every conceivable safety feature has been integrated into this device to make it as reproducible as possible. So the first step here, and I'm going to have one assistant just hold the scope. So I think you can all agree that right now the gallbladder is up against the duodenal wall, and you did see earlier that it's not adherent. There's a ascites fluid between the two, but we found a spot where the two structures are close to one another, and we can measure out the distance here, or the size of the gallbladder. It's about 4 centimeters. And we'll measure out here. The duodenal wall is here. This is the gallbladder wall, all right? That's the echogenic layer is the gallbladder wall, and this is the duodenal wall. And this is the muscularis propria of the duodenal wall. So we're going to be going between, through these two wall layers, with a thickness of, let me just get that for you. Where's that measured out, the thickness here? Yeah, it's 5 millimeters. 5 millimeters, the thickness of 5 millimeters. And now we'll go ahead and measure the size of the gallbladder. We'll go from the outer wall, you can see it there, and we'll measure it all the way down here, and that is 4.5. So 4.5 by 4 centimeters, round structure. And you can see the echogenic material in there. I don't see anything that's shadowing, so I don't think there are any stones in there, but clearly the contents are very thickened, and there's some debris in there. All right, now the first step is to advance the sheath out, so I'm going to unlock. So there's an unlock here, and if you can zoom in on this, now I have a view of what you're seeing. So you can see there's a lock and unlock button, and this allows me now to advance this lower hub right here, and I can advance this out. So what I want you to do is watch as I advance this out. You're going to see it come out of the working channel, and my elevator is fully open, and you can see it coming out right there. So hopefully you can see this. This is the tip right here. All right, so we're going to keep advancing this, and you're going to see that this is going to tend to push away. So it's very important to have your assistant holding this position very securely. What we're going to do now is we're going to apply cautery to help us penetrate through the wall of the duodenum and the wall of the gallbladder. So we will go through this open space where there's ascites, but hopefully what we want to accomplish is that we can get quickly into the gallbladder lumen, and if we're there, we can immediately deploy the distal flange of the stent, right, without any kind of exchange. All right, so now Kate is going to hook this up to here, right there, is going to hook up the cautery. So there is a port here for the cautery that's hooked up. I'm going to just apply some gentle pressure here, and then I'm going to press on the pedal using pure cutting current. That's very important, to use pure cutting current. And I'm going to then advance into the gallbladder, and I'm going to apply a little bit of cautery initially just to sort of prime everything and then advance forward. So I'm going to step on the cautery for a little bit and then start to advance forward. Are we ready? And we've got pure cutting current. We've checked our settings. Okay, good. So let me just hold this a little bit like this. All right, 1 second here. Let me just pull back a little bit like that. That's right. That's good. So I've got my assistant holding here. I'm stepping on the current, and I'm pushing forward. And I'm in. Now, I'm going to show you I'm inside, and I'm going to push in as far as I can. Okay? I'm in as far as I can go, and I'm now going to lock this sheath here. Take this cautery off. I'm through the walls. You can see it very nicely. I have now locked the sheath. So the sheath is not going to move at all. I'm going to take off this safety pin here. Pops off like that. I'm going to deploy the distal flange, and there's a lock-unlock button here. You can see I've shifted it to the right. Now I'm going to pull back very slowly, and in a moment, we should see the flange open, and you see it open right there. See it? It's opened up like a disc, like that. Okay, so now I have the distal flange open. It clicked, which means that there's no risk that the proximal flange will accidentally deploy. I have to actively deploy the proximal flange, but I'm not going to do that until I'm in good position to deploy it. So I'm going to unlock now here. I've unlocked the sheath, and I'm going to snug the sheath up like this. So I'm pulling up, and I'm going to pull up until I see that flange sort of deform a little bit. And you can see it deforming now. Okay? So now, as soon as I see that deform, I'm going to lock this again, and now I'm going to deploy the proximal flange. Now that proximal flange is going to deploy in the working channel of the scope. So I'm pulling back, and I've now deployed the proximal flange. And now I'm going to unlock the sheath, and now let's get the endoscopic view. So I want to have the endoscopic view, and you can have the view of me. And I'm going to pull away from the wall, and as I pull away from the wall, I'm going to give some air, and I'm going to push the stent out. And I'm looking right now. See the stent there, right? And I'm pushing it out. I'm pushing it out by pushing the sheath forward, and now it deploys. So now the proximal flange has fully deployed in the duodenal bulb. You see it there. Okay? So now I have deployed the proximal flange, and that is hugging the inside of the bulb. You can see that on the image, on the endoscopic view. And then we can try to recapture. Why don't I just go ahead and just pull this out for now. Now we do have the option, if we wanted, we could put a guide wire through here. There's no need to do that. So I'm just going to pull this out. As you may note, I have no fluoro on. No, I have no lead on. So I'm not using any fluoro for this procedure. I'm going to pull this out now. Let's just put the hydrogen peroxide in now, since we're here. Okay, we're just going to throw some hydrogen peroxide, and then we'll come out. That'll help break up the clot. Okay, hydrogen peroxide. Okay. Yep. Good. Nice. Nice. You can see the lumen of the stent very